Welcome back. So we've seen what happens when we move an object using add actor world offset. And we've seen that sweeping plays a very important role when it comes to detecting collisions. And when we're using add actor world offset, we have to use the query system to detect collisions because the query system is what we use when sweeping. So this should sweep Boolean variable determines whether or not these objects will stop when they meet or pass through each other. Let's now take a look at moving our actors in a different way using set actor location. So these two actors over here, they look the same as those two actors over there, but they are different. Let's go ahead and see what these blueprints look like. First, I'm going to close the blueprints that I have currently open. And I'm going to right click on this actor and choose Edit BP Ball Set Actor Location. This is another actor class. And if we go to class settings, we'll see that the parent class is BP Ball. So it too is based on BP Ball. It's inheriting qualities such as the ball mesh, the arrow, that widget, and so on. But its event graph is slightly different. Yes, we're calling the parent version of tick, just like our other actor we looked at, and we're checking whether we should move, but once should move is true, now we're moving the actor in a different way. We're calling set actor location. In the last video, we were using add actor world offset, right? Set actor location sets the location specifically to a new location. Now, what are we doing here? We're just taking our new location variable, which, by the way, if we look up just a little bit, we'll see that in begin play, we're setting new location to the actor location. Get actor location is being called, and we're setting new location there. And we're calling the parent version of begin play. That's the BP ball version as well. Now, what we're doing in tick is we're updating that new location. We're getting the actor forward vector. We're multiplying it by a float. What float are we multiplying it by? Well, speed times get world delta seconds. So we're getting that forward vector. We're scaling it by just enough to move this object at this given speed. And we're adding that to the new location and updating new location. So we're setting the new location to just a little bit more forward than it was last frame. We're doing this every frame, calling set actor location, passing in should sweep. Now, if we go back and take a look at these actors and look at should sweep in their details panel, we see for this one, it's unchecked, so it's false. And for this one to the right, it's unchecked, so it's also false. So if we press play, let's see what happens when they meet and they pass through each other, just like they did over there in the first panel. And that's because we're not using sweeping. Set actor location is just like calling add actor world offset. We're setting that location directly. And if that means we're setting the location such that two objects are overlapping with each other, so be it. We're not sweeping, so we're not detecting collisions. Now we can go and take a look at the collision settings for ball mesh in the actor, and we can see that, well, it's set to block all dynamic, but really this is not a whole lot different than the collision presets for the static mesh asset. And in fact, we can change this to default so that they are using that static mesh asset collision presets. And we can select the ball mesh on each of these instances in the world and see now that their collision presets are set to default. So we'll still see the same result if we press play. They will pass straight through each other. That's, of course, unless we enable sweeping. So we can check should sweep on both instances of these actors and press play and see that as soon as they meet, there they go, they block each other. And this again is using the query system. Now you might be wondering, what if one of them is sweeping and the other is not? Well, let's see what happens in that case. We'll let the left actor sweep and the right actor will not sweep. We'll uncheck should sweep. And let's see what happens in this case. Well, notice that object B, the one to the right, which is not sweeping, was never stopped. As soon as these objects meet, object B continues, and object A is stopped until there's no longer a blocking piece of geometry in the way. So object A shows what happens when sweeping detects a collision, and object B shows when no sweeping is used when moving the object, when setting the object location. So that's an interesting side case. And again, sweeping is using the query system and not the physics system, which means we can take our ball mesh, we can browse to that static mesh and open the static mesh editor to check out its collision presets here. And again, we've changed this to custom and it's using query only. So these objects are using query only and not using physics at all. So it's worth noting that we can get a blocking interaction without using physics. We're using the query system only. Okay, now let's move on over to the third panel here, because this is using a different actor, but we can right click on this actor, go to edit. We can see it's called BP Ball Add Actor World Offset Begin Play. Let's go ahead and open that. And we can see that here in the event graph, we're just calling the parent version of Begin Play, which the parent for this class, just like all the others, is BP Ball. And remember, in BP Ball's Begin Play, if we go to our blueprints, ball, and open BP Ball, and take a look at Begin Play, we're doing a couple of setup things. And after a delay of 1.5 seconds, we call Start Moving. Now, the parent version of Start Moving just sets should move to true. But if we look at BP Ball Add Actor World Offset Begin Play, all it does is calls parent Begin Play. But it has its own implementation of Start Moving. And what it does is it calls Add Actor World Offset just once using a delta location of the forward vectors scaled by teleport distance, which we can see is set to 200. So all this actor does is once it starts moving, it teleports over here using Add Actor World Offset. So this display actor here should actually say Add Actor World Offset and not Set Actor Location, but it doesn't matter. What does matter is whether or not we're using sweeping. And if we select this actor, we can see in the details panel that should sweep is not checked, so we're not using sweeping. So let's see what happens when we add an actor world offset just once. There it is. We've teleported to the other side of this box. So because we're not sweeping, we're not detecting any collision in the way from point A to point B. We're just going to teleport to the other side of it. However, if we enable sweeping for this actor by checking our should sweep Boolean variable and pressing play, let's see what happens now. Notice that it stops in its tracks. Sweeping detects collision in the way. So adding a single world offset is going to stop that object just short of any blocking collision. So this just shows us again how sweeping is keeping our objects from passing through any other objects that are blocking it. And of course, this depends on the two objects' collision responses to each other's object types. We know that this particular actor has its ball mesh, and we can check its collision presets. Again, this one is set to block all dynamic. If we want, we can set it to default, which will default to the static mesh, SM Sphere 30. Its collision presets is only using the query system, query only, but its collision responses are set to block all collision channels, and its collision object type is world static. We can take a look at the collision presets for this box here by selecting its static mesh component, taking a look at its collision presets. It's also set to default, which means we'll have to take a look at the static mesh asset for the box. We can do that by finding that static mesh asset in the details panel, browsing to it, and double-clicking it to see what it looks like here. And taking a look at its collision presets, we see that it's set to block all. It has a world static object type. It's using query and physics, and it's set to block all collision channels, including world static, which is the collision channel used by our SM Sphere 30. It's world static, so SM Wall has a block response to world static. Therefore, Because both pieces of geometry are set to block each other's collision object types, we expect a blocking response. And if we're adding a world offset with sweeping, we will get that blocking response, as we can see here. And again, all of these movement methods we've used so far only use the query system. They do not use the physics system when detecting those blocking collisions. To see what happens when using physics, we're going to need to check out the other side of the room where we're using physics to move our objects and not add actor world offset or set actor location. So in the next video, we'll move over to the panel labeled 4, and we'll see what happens when we move objects using forces. Awesome job. I'm going to go ahead and close out of all my tabs, including project settings. I'm going to save all, and I'll see you in the next video.